Yes, it's time to delve into feature engineering. That's the step 4 in in supervised machine learning process. So feature engineering is a crucial step in the supervised learning process that involves transforming or creating new features from the existing data set to improve the performance of machine learning models. The goal of feature engineering is to extract the most relevant information from the data and represent it in a way that enhances the predictive power of the model. So let's again uh, categorize various techniques into various groups or sections. The first section is feature selection. So under the feature selection, the methods that we have is the first one is inferential statistics, using the application of inferential statistics. So this is also called as univariate selection. So selecting features based on statistical tests like chi-square test, ANOVA, that is analysis of variance, or correlational analysis. Chi-square test is for the categorical variable, and then ANOVA is when you have a continuous variable as a dependent and then categorical variable as an independent. So in that case, ANOVA can be used. And in addition to that, we have other tests like t-test, f-test, and g-test. So this is using inferential statistics for the feature selection. This is called the univariate selection because you can select variable at a time, one variable at a time. So again, if you want to learn and understand the inferential statistics intuitively, I would request you to watch my intuitive inferential statistics for you course. So I have explained most of these topics: t distribution and t test and ANOVA, f test, chi-square test, and everything in detail there. So okay, so with this the univariate selection technique is used to select a feature. Then what all other methods that we have? Recursive feature elimination, iteratively removing features with the least importance based on the model's performance. That's called recursive feature elimination. Then the third one, we have the feature importance, assessing the importance of features using the ensemble based methods like random forest or gradient boosting. This is called feature importance. Okay, so these are the some of the other techniques that we use to select the features. Okay, so the second section is nothing but your feature extraction. Under the feature extraction, we will be using techniques such as data reduction. So data reduction, sampling is one method, aggregation, dimensionality reduction methods. These methods we will use it heavily to reduce the number of features. Basically, that's what is your dimensionality reduction methods. Example: principal component analysis, PCA, linear discriminant analysis, LDA. Then we have T distributed stochastic neighbor embedding, that's a TSNE, and autoencoders. Okay, so this is one method. And in addition to that, what we have here is data transformation techniques. Data transformation techniques, which are normalization, standardization, log transformation, data encoding techniques such as label encoding or ordinal encoding, which is for the ordinal variable. Then one hot encoding, which is for the nominal variable type. Then dummy encoding, again it could be nominal variable. Then effect encoding, hash encoder, binary encoding, and target encoding. So these are the encoders that we use under the features or feature extraction, and we use these techniques to basically convert a variable into a proper feature. Okay, and obviously what we have is the last section, which is create a new feature by combining. Create a new features by combining or transforming existing ones. That's what is called uh, the third section that we have here. So creating new features by combining or transforming existing ones is a crucial step in feature engineering, which can enhance the predictive power of a supervised learning model. So first one is mathematical operations, such as addition or subtraction. Create new features by adding or subtracting existing features. And the second one is multiply or divide features to create new ones. And the third one is take the logarithm or exponent of features to transform them. And the other way is using interaction features. So interaction features are created by combining multiple features to capture interactions or relationships between them. For example, if you have features A and B, you can create a new feature AB by multiplying cap A and B together. This is called interaction features. And the third one that we have here is binning or discretization. Binning or discretization. Binning involves dividing a continuous feature or continuous variable into discrete bins or intervals. So it can be useful when there is non-linear or non-monotonic relationship between the feature and the target variable. And the last one that we have here is domain specific transformations. Whatever we have seen or specific to supervised machine learning algorithm, but I have added one more techniques basically which are domain specific. I've taken NLP example. So domain specific, depending on the specific domain or problem, domain specific transformations can be applied to create a meaningful features. So for example, in natural in natural language processing, features like word count, sentence length, or TF-IDF scores can be derived from text data. So those are actually domain specific. They are applicable to NLP, natural language processing. So it's important to carefully consider the domain knowledge, explore the data, and experiment with different feature creation techniques to determine which ones are most effective for improving the model's performance. So now the question arises. The question may pop up in your mind, that is, what's the difference between feature engineering and and DA, that is your exploratory data analysis, are whether they same? Is EDA and feature engineering are same? Are they same? Are EDA and feature engineering are same? Are they same? Are EDA and feature engineering same? No. Exploratory data analysis, EDA, and feature engineering are not the same. While they are related and often performed together, basically sequentially, they serve different purposes in the supervised learning process. So, exploratory data analysis focuses on understanding and summarizing the data set to gain insights into its characteristics and relationships. It involves descriptive statistics, data visualization, and data profiling techniques. EDA helps in identifying patterns, trends, outliers, and potential issues in the data. So, the goal of EDA is to explore the data set and inform subsequent steps in the analysis, such as data cleaning and feature selection and modeling. So, feature engineering on the other side, on the flip side, feature engineering involves transforming the existing features or creating new features to improve the performance of the machine learning model. So it's a creative process that leverages the domain knowledge, very, very important domain knowledge and data understanding gained through EDA. So feature engineering can include tasks such as selecting relevant features, handling categorical variables, creating interaction terms, scaling or normalizing features, and applying mathematical transformations. The objective of feature engineering is to provide the model with more informative and discriminative features that can enhance its predictive capabilities. So, in summary, EDA is focused on understanding and exploring the dataset, while feature engineering is about transforming and creating features to improve the model's performance. So, EDA helps inform the feature engineering process by uncovering insights and patterns that guide the selection and creation of relevant features.